Hello, everyone. We have another Australian special, as some people like to call it. It's early in the morning. We will not be going as long as we did yesterday, or yeah, yesterday morning technically. Um, because I don't want to be. I was streaming until basically like close to 6 a.m. yesterday, and it's about 10 to 3, so we're starting a bit later, but I don't want to go as late, so. It's mostly going to be like updates and maybe making a few tweaks. Um, Nothing too crazy. It's 4:53 in Australia right now. Nice. All day, every day, no days off. Yeah, I kind of like these later streams. It's very quiet. Nothing's going on in the house. The dogs aren't running crazy. It makes it for a nice time to stream. Even though, unfortunately, some of our Western Hemisphere friends can't tune in as much. All right. So those of you who might have seen my tweet on Twitter, for those who haven't, I brought it up on stream, but I was able to trigger code execution. I was able to get the instruction pointer to AAAA. So we've pleased the gods. We've done the ritual. Now that we've taken it to A's, we can make it do cooler stuff like patching the kernel, or in the BSD VM, probably just calling printf in the kernel, and then uh, get the cleanup routine down and exit back to userland. So, yeah, this was cool to be able to see. So I'll kind of walk through the panic a little bit. So those of you who tuned into our previous streams knew that I was trying to basically fake a file pointer, and then using that, I would fake a file operations table and take hijack code execution by overwriting or not overwriting, but faking the ioctl handler in the function table in the kernel. So as you can see in the stack trace, that's exactly what I did. It calls sysioctl, and then when it gets there and it goes to call like the file operation, it goes to the hex 4 ones. So there's a few things I wanted to cover that are relevant that I had figured out after yesterday's stream. So let's talk about them. So we ended off yesterday's stream. I was hoping to get to this point on the stream yesterday, but I kept running into issues where I wasn't faking the file pointer properly. It wasn't slotting in right, and I'll talk about why now. So this is pretty much where we left off yesterday. We managed to get our data into the file pointer stack, but the data wasn't arranged properly. As you can see on the right side, the fake file pointer was allocated in userland at hex 801018060. In the kernel, it was reading it as 08, a bunch of zeros, 60, 80, 0101. So you can see like the bytes are right, but they're in the wrong places, right? It was like somebody played Scrabble with the bytes, basically. So I thought, and like a few of us from chat yesterday thought that it was an endianness problem, because for those that don't know, there's two modes of endianness. There's big endian and little endian. On FreeBSD or BSD like systems using a BSD networking stack, the networking stack is always going to be in big endian regardless of what your host system is. Most systems nowadays are running little endian. I think the only systems that are really running big endian natively are like certain servers. So that's what we thought was going on here. We thought that, okay, well, we are dealing with the networking stack, and I wasn't accounting for endianness, so maybe that's why the bytes were out of order. That was actually not the case. That was a bit of a red herring. The problem here was actually an off by 4 error. Somebody in the RE server helped me figure that out, so thank you to that person, because they probably saved me a lot of time. So what was happening? Let's take a look. So these cluster M lines are spray of the file pointers, right? Now, here's the problem. You can see the data, the pointer here, the last byte is hex 4C. The problem is, when UNP externalize is called, all of these pointers are aligned to an 8-byte boundary, right? Because they have to be. So, because my data was kicking off at hex 4C, and the pointers were aligned to hex 8, I was off by 4. I didn't account for those leading 4 bytes. So that's what there was a shift. The bytes were out of position by 4 bytes, right? So when I accounted for that shift, I ended up discovering that I actually don't want to swap the byte order because that was broken too. When I removed the bswap64, then it worked. So we do not need to account for endianness. That was just a red herring that we encountered. The problem was actually the off by 4. So it was kind of a subtle issue. And it was good that it got caught early, because that could have been a tangent that took me down a rabbit hole for a while. Once we fixed that issue, we got closer. I wasn't able to get to code execution right away from that. There were a few other steps needed, and I'll go through those now because they're of interest. So when we left off yesterday, I was faking what I knew I wanted to set up in the file object. So let's scroll up. Where do I fake the file object? Right about here, right? Yeah, right at the top. So before, I had this basically for faking the file object. I set up a fake file operations table, and I set up the hex 41 RIP hijack in the file operations table for the ioctl handler. There were actually a few more fields that I needed to fake in order to get it all the way. So I had the fields there and I cut them out. I'm just gonna keep them on hand so that I don't forget what they were. Okay, so the first one is the ref count. So let's go into Watson and we'll go into the ref count. So we'll go to the sys ioctl function on line 626. Okay, so what happens when you call the ioctl sys call? We'll kind of work our way down. First, it checks your command that you provide and checks that it's actually a valid command. For those who don't know, on most Unix systems, I think it's the exact same on Linux too, although it is a little bit different on the finite details, but essentially, when you call ioctls, the size is bundled into the command you pass. So a command actually has multiple segments to it. The highest bit represents if it's a read, a write, or a non-IO related operation. And then the lower bits are used for the size, and then the middle bits are kind of used for that identifier for the switch statements and stuff. So yeah, it's doing a bit of verifications on the commands. It's then pulling the size out. You can see the comment there, interpret high order word to find amount of data to be copied from, /from user's address space. Once it does all the necessary information to get the data that the user wants to either read or pass in from user space, it'll call the kern ioctl function, which does all the heavy lifting. The syscall here is basically a wrapper around kern ioctl. This handles getting user-controlled data in or getting a user-controlled pointer in for when the copy out happens. It calls kern ioctl, lets that run, and then it copies out whatever results to the user-provided buffer. And then it exits out. So, kern ioctl. This is like gonna contain a lot of the meat of our path for code execution. So it calls a few macros here. These are not really important, these audit args. I don't even know exactly what they do, but I just know they're not really important for the exploit. You know what? Let's just see. Yeah, I think this is for like logging or something. It's yeah, it's some debugging functionality. Honestly, this probably isn't even built into the kernel. You probably have to configure that to even do anything. So yeah, this is the important call we care about though. At the top of kernel octal, it calls fget. And what this does is it takes your thread descriptor and it takes your file descriptor and a few other things and a destination pointer for the file pointer, and it does a lookup on your process FD table to look for the FD you pass it, and then it'll return the file pointer. Or no, it won't return it. It will place the file pointer in the buffer you specify for FP. So this is 2406. Let's go there. This is just a wrapper around underscore fget, which just gives you a higher degree of control over what's happening. Right. So here's where we meet issue number 1 that I had to fix up. You'll notice at the top of this function, it does a few checks. It checks if the thread descriptor is null, which this should never be null. This is probably just a failsafe, and they wanted to be safe, but this should never happen. And then it pulls the FD table, the file desk table from the thread descriptor from the current process. And then it tries to get the pointer by using fget unlocked. Now, this is the weirdest looking code I've ever seen. This is doing lockless fetching of the descriptor. Because when you're doing stuff with files, you have to understand, you have to be very careful on Unix, because anybody can close, like, they can delete a file, or they can close a file while it's being operated on. And that opportunity can cause a lot of problems if you don't account for it. A lot of UAF potential. So you have to keep some reference counting on the file pointer to make sure that there's no other references to it before you drop the reference. So that's what they do here. But for some weird reason, they thought, let's not use mutexes or locks or things that are designed to help with this kind of thing. Those, I guess, they're too much of a performance hit for BSD. Maybe at the time it was, because this code's pretty old, right? So maybe at the time it was worth the trade-off, but essentially they do some weird hack here where they read the file pointer from the process's file, like FD table, and then they retrieve the count, and then they do an atomic instruction which will fetch the count again and then check it against what they already have to make sure that it's the same, and if it is the same, then they increment the ref count. It's really, I don't know why they do it this way. I feel like this is just so weird, but I guess it works. Like, this function is called a lot in the kernel, so I could see why they would want to reduce the overhead of a lock. So I guess it kind of makes sense that they would want to do it locklessly if they could. But this is just such weird code. But essentially, what this is doing is it's checking the ref count, and what's important to note is if the ref count is 0, you can see right here, count equals fp f count. If it's 0, continue. And this is an infinite loop. There's no condition in the loop declaration to get out of it. So if your reference count is 0, you're just gonna stall here forever. You're just gonna infinitely loop. You're gonna hang. And that was the issue I encountered, because I wasn't faking the file reference, the reference count of the file. So because I was leaving it at 0, when it got to this point in the exploit, when I tried to invoke ioctl, the kernel would just lock up. So that was the meaning behind change number 1. Because I'm not really sure what the ref count was on the file before, or what the ref count should be, I just make it something really high. I make it 1337. Isn't this basically just double-checked locking? Not really too unheard of. Um, yeah, it's just, I don't know why they wouldn't, uh, did RCU, the concept of RCU, not really exist back then? I don't know, but, I just feel like there's other primitives that would have been better suited. But maybe that's just me. So yeah, that was the first thing. Like I said, I made the reference count really high because I didn't know what it was supposed to be, so I just made it 1337. You know, put it to a meme value. The next problem was the fact that higher up in the stack, it does another check. It does a check on the type of the file, and if it's not a file that's supposed to be able to have ioctls issued on it, then it's not going to do anything. It's going to bail out. So these are all the different file types you can have. You can have a vnode, a socket, a pipe, first in, first out, KQ, crypto, MQ, shared memory, semaphore, pseudo terminal, device. Capability, I'm not sure what that is. I guess that's a permission, something for permissions, and then a process descriptor. You'll notice none of these types use 0, right? And I memset to 0 any field that I don't explicitly initialize. So because it had an unknown type, it would bail out. It would be like, I don't know what type of file this is. I'm just going to jump out of here because if it doesn't have an ioctl handler, then we're screwed. We're going to blow up. So I had to fake the type as well. Right? So that brought ftype into account. I just set it to dtype socket because that is what it is. It's socket. The final check was in the kern ioctl handler itself, I believe. Yeah, so in kern ioctl, it will check if the flags on the file allow it to either be read from or written to. If both of those are false, if you have no read or write capability on that file, it will drop it and return bad file descriptor, right? Because you're not supposed to be able to operate on it if you don't have those, if those flags are not set. So that was the third thing I had to fake in order to exploit the issue. I had to set it to read-write flags, and that's where I did that. Once I had all of this faking going on, I managed to get it to code execution eventually. So yeah, that was mainly what took me from where we ended off yesterday's stream into, the Twitter screenshot of getting code execution. Those who were here yesterday may also remember that Teamstar briefly popped on towards the end of the stream. And we were talking about ways we could potentially stabilize the exploit. Because right now, the stability is kind of shoddy. You're talking about, 40%, roughly, 30 to 40% reliability. Which is, it's not terrible for something like a jailbreak. But it's not great either. You want to aim for as high as possible. Now, something I've said on the streams, and I'll repeat, is that the factors that are contributing to the instability on the VM will not be as bad on the PS4. So I think the stability on the PS4 of the strategy will be better than what it is on the VM. That said, the more we can improve it on the VM, the better we're going to be, at the ground floor when porting to the PS4. The better stability we can have, the better, right? You want the highest you could possibly achieve. So Teamstar and I were kind of talking about how we could potentially try to increase stability. Mainly when it came to, right now, the race is basically a one-shot. If you lose it, you're done. If you win it, then that's great. Ideally, you would try to make it more likely for that race to succeed by just running it more times. You're brute forcing it, right? Which should be possible. I think we worked out a basic idea of how we can do that. There's 2 points of failure in the exploit. One is we fail to get the overlap up front with the double free, which is not fatal, just annoying. It just means you have to rerun the exploit. The second way the exploit can fail is if you do get the double free, but then you can't win that race of the interleaving between the corruption and the usage of the file pointer stack. If you lose that race, then you are screwed, because as soon as the process exits, the kernel blows up. And that's because the cleanup routines are working on corrupted data. They don't know what to do. They blow up. I think an assertion failure basically gets triggered. So if we, like, that's not a problem if we get code execution, right? If we win the race in our kernel payload or our kernel drop chain, we can write code to fix up, or at least, prevent that memory from even being operated on in cleanup. Just let some memory leak, and then we won't blow up. But if you don't get a chance to run that kernel payload, you are not going to be able to exit that process ever, which is quite problematic, obviously. So, yeah. I think where I'm going to be focusing now is on trying to allow process reruns. That's probably the place that makes the most sense to go. What if first you fail the race? Can you win on a second run in the same process? I believe so. That's kind of what we were thinking about with Teamstar. Because the crash only happens when the process leaves. So as long as the userland process doesn't crash, or you don't explicitly terminate, but like returning from main or something, you should be fine, from my tests. So what we were thinking was basically making the spray so that it would run for long enough to be able to catch the pointer that gets released from the readfd. That way we can recapture it to run the race again. And that should be relatively straightforward. Where it gets tricky is identifying where we have the overlap, because we don't have tagged packets anymore at that point. So we would have to create tags via the pointers we use for the fake file pointers. So it's a little bit weird, and it will be annoying to do in like a WebKit ROP chain, but it might be worth it. So, did you see the recent discovery on those new undocumented Intel CPU instructions? I saw the article that mentioned it. I'm really not too surprised. Generally, like across chips, there are some like hidden instructions. I remember seeing a talk from Christopher Domus a couple years ago at DEF CON, and I think he gave it a black hat too. It wasn't like a widespread thing. It was only like one or two specific CPUs, but they had like a backdoor instruction set. And he managed to find that by running, I think it was Sand Sifter. But yeah, basically fuzzing for like undocumented instructions, trying to look for instructions that you would think would be invalid, illegal instructions, but actually end up doing something. And the way that works is really fascinating. You do like a timing attack on it, if I remember correctly, but it was really cool. Yeah. Which completely control microarchitectural state. Yes, they can modify the microcode. Yeah, it's probably like a debugging trapdoor or whatever that they left in there. Like Z said, that's kind of what I expected, that you would need to have the CPU already unlocked. Because yeah, Intel ME is gonna protect that. So it's still cool though, for sure. Watched it last week. You're correct. Really good talk, by the way. Yeah, I thought it was really neat. It was interesting because DEF CON talks are usually like, I went to a few of them and I was kind of disappointed, but that one I went to with a few friends and it was really awesome. You're not hearing the beeps? I don't have it muted. It is set up as a source, so not sure why that wouldn't be coming through. Um, try doing it quick. Is maybe the URL down for where you're hosting the endpoint that I use for the OBS source? That's the only thing I can think of. So yeah. One funny thing about this, the way this is triggered, by the way, is I managed to capture this screenshot in the VM while it was shutting down. I was able to like quickly grab it. This information, for whatever reason, doesn't actually make it into the core dump when, like, usually when FreeBSD crashes, it's gonna write what was in the message buffer of the last run to a core dump file so that you can do like post-mortem, right? Post-mortem. So you can log in, you can read the crash dump file, and you can see what happened. That's what I tried to do here. For some weird reason, it just shows panic page fault, and it shows a bit of a stack trace, like you can see kern ioctl and then call trap, but it doesn't have the like pointers or anything that were involved. Like you can see it looks very different from what I have on Twitter. I don't know why it does this. If somebody can shed light on that, I would be interested to hear, because it almost seems like something got corrupted in the crash dump process or something for this to happen. But I don't know the specifics of why that, why that's going on. So I would be curious. It's not overly relevant, really, but it's just something that I would be curious about, like I said. Yeah, so that explains the file pointer fake. There is one other additional change that I made, and it seems really silly, but it did actually help a little bit with stability. And that is this. You can see on line 683 to 686, all I do is run a for loop that runs 400 times and it does nothing. It's just a busy loop. And that delays the readfd from happening by a few nanoseconds or whatever, and that ends up making it so the race is more likely to succeed. The reason I'm using this like hacky loop, which is like generally when you're busy waiting, like if you're writing, like let's say you're writing an operating system and you want to write a busy wait function, this is really a bad way to do it because this is really inconsistent. The amount of time that this for loop is going to take to execute is going to change every time you run it, because it's going to depend on, the CPU state, what CPU you're running on, etc. But I can't actually call nanosleep, which would be the proper way to do it, because the act of even calling nanosleep, even if you use like a 1 nanosecond sleep or a 0 nanosecond sleep, is too long. You delay the read by too much, and you will lose the race every time. That's how touchy the race window can be. And it's probably some other stuff too. Like I think nanosleep, it's probably sleepable. So if it goes into the nanosleep function and then it sleeps somewhere in there, you're screwed. That's probably what happens actually. The act of calling nanosleep is probably fine, but if it like the way it works interacting with the scheduler is probably what messes it up. Doesn't the compiler optimize that out? And why wouldn't the compiler optimize out that for loop? I was kind of thinking that too. I think it's because I'm running on a much older GCC. I did check. That was in my mind. I made sure to check in Binary Ninja to make sure that it wasn't being optimized out. Blackbeard Hex 14E, thank you for the Twitch Prime, dude. Welcome in. But yeah, I did totally verify in Benja that the loop was not optimized out. If it was, I would have just specified the O0 flag, so it wouldn't have been a big deal. But I was surprised that I didn't even have to, and I think it's just because I'm running... Like, FreeBSD 9 is really old, right? Is it V? I don't know. What is it? Yeah. This is running GCC 4.2.1. That's the version that's in ports. So that was what I had to work with. I could maybe try to build some newer GCCs, but I don't really have a reason to. I've refreshed it now, Z, by the way. Yeah, the only thing I don't have, like, since that GCC is so old, I don't have C11, which was a little bit annoying. You'll notice in my exploit code, every single for loop has, like, I is already defined. I couldn't define I in the for loop because I'm stuck on C99, but that wasn't too much of a big deal. Maybe because of our I isn't a temporary. It could be that too, yeah. And again, that was because I was stuck to C99, so I couldn't do in-loop declaration, as it's called. But yeah. So this crappy loop does help with the race. I don't know if I'll keep it. I might try to find a better solution. But it works for now. So it's CN, welcome in. Z is okay. Anybody who tried to beep while the beeps were down, Z's refunded your points. Gotta make sure that nobody wastes points. But yeah, we do have a working race through the ioctal. See if I can run it on stream. Anytime I try to run this shit on stream, it usually doesn't work, because that's just how it is. So we'll see if I can run it on stream, because it would be cool if I can. Been a bit since I've done PS4 hacking. Yeah, console stuff is like, it's got a fun allure to it. Let's see if I can run this on stream and if it'll work. If it works, we will see a panic show up in the VMware window. There we go, it worked. Look at that. You know why? Because I said it wasn't going to work. I said it never works when I do it on stream. I tricked it. I made it work. So, as you might, it was kind of a blink and you miss it kind of moment, but if you looked at the panic while it was briefly shown, it showed instruction pointer hex 41414141. So, yeah, we got the crash. That was cool that it ran at first try on the stream. The demo gods are pleased. If I used any other value other than like A's for the instruction pointer, probably wouldn't have worked. You gotta please them before you run it on stream. Any thoughts on the exploits working with dev kits without additional changes, or do you think it will need special changes to the exploit chain? Oh, you mean like the retail exploits? Okay. It's an interesting question, because dev kits are a little bit weird with how they function. Their hardware is a little bit different, right? I don't actually know if there's, the biggest difference you have to look out for is like the CPU and the memory. I don't think dev kits have a different amount of memory, like a different memory architecture to them, but they might have a different CPU. I don't know if, does anybody know if PS4 dev kits have a different Jaguar CPU? I imagine it, well, that wouldn't really make sense, right? You'd want the CPU to be the same as your target that you're developing for. Valika spam and beeps. You guys are crazy with the beeps. Test kit is the same as retail, so some of the exploits have modified addresses. Yeah, so I don't know in regards to the hardware what the difference is. I know for a fact, though, that the kernel is different for dev kits. Dev kits do run, they have like a modified kernel build. They have some like if defs and stuff put in. Syscalls that are stripped out on retail systems are in dev kits. The debugging, like mdebug stack that's partially stripped out on retail exists on dev kits, obviously, because you would need that functionality. So there might be a bit of difference when it comes to the stability of the exploit. It's hard to say. It's mostly like theoretical. I've never owned a dev kit, so I've never really been able to test that sort of thing. Mostly, though, I think it just comes down to the offsets being like needing adjustment. When it comes to vuln research, dev kits are a little bit more interesting because dev kits will have more attack surface exposed. Like it's a lot easier to jailbreak a dev kit than it is to jailbreak a retail system, for obvious reasons. So Yeah, I've always kind of wanted a PS4 dev kit. They're a little bit too much though. They're it's hard to justify buying a dev kit when I don't really need one, if I'm being honest. I can do the debugging with the retail units I already have that are jailbroken. Dev kits, the one thing that would be nice that a dev kit could offer is the ability to jump between firmwares very quickly, because dev kits can downgrade. That being said, with the glitch attack now, I don't even know if that's even worth it, really. So, you have an entry point 100% of the time. Yeah, I mean, if you want to do like fuzzing and stuff, a dev kit would probably be super useful. Um, but man, they're like what, $1,500 or something at this point. Bit too much. If I was gonna get a debugging system, I'd probably want to get a test kit. I think a test kit would make a bit more sense. They're a bit more limited, but for like exploitation purposes, I think they'd be fine. Good morning, Shotjar. So yeah, so I'll bring up, I guess, what Teamstar had kind of proposed, what we kind of worked out yesterday for possibly increasing stability. Even though stability is decent as it is. Um, so essentially, what we would do is we would make it so we could run this race multiple times. So right now, let me walk through how the race works a little bit, because um, you need to understand a bit of that background context for Teamstar strategy to kind of make sense. So at this point, we have an overlap. We have two different things that share the same mbuff, right? So we have we can fire off a use after free at any time. We basically have a controlled use after free primitive. So by freeing it once from the UDP sockets, we can get it reclaimed by the stack of file pointers for the TCP socket pair. Then we can race on one thread reading those file pointers, and on the other thread interleaving a smash so that we can corrupt it to make it do useful things, right? So that we can control a file pointer that gets created. But we have to do that after a check runs on the mbuff header, or we won't be able to get that data to be used, right? That's the reason we have to interleave. So that is kind of straightforward in terms of how it works. What's the problem, though? Where do we blow up? What goes wrong? Primarily, what goes wrong is right here. So the left is thread 1, the right is thread 2. The left is doing the read operation, and the right is doing the smash operation for the UAF, right? So right here, we're freeing it, we're causing use after free, and then we're reclaiming it right away with our stack of custom file pointers. Problem here is mbuffs are used a lot in FreeBSD. Any other services that are running that do anything networking, or even if they're not doing networking, even if they're doing local IPC, they're going to be using mbuffs to do that. So like the SSH daemon is going to be using mbuffs a lot. Any other IPC mechanisms that, like any number that I don't know off the top of my head, are going to be using mbuffs. So anything that frees an mbuff after we do, but before we try to reclaim, is going to pollute the free list, right? So for those that don't know how a free list works, let's see if I can pull up, some helpful visual aids here, right? So basically, how the memory allocator, or UMA, works in FreeBSD is you have these nodes in a linked list. And this is called the free list. So when an allocation gets made, it'll take whatever is at the top of the free list, take it out of the list, and give it to you, right? So if things get added into that free list after your target object, you have to get those out first before you can get your object out, because it's basically first in, first out, right? So because shit ends up polluting the free list in between these two operations, we have to. This has to run like maybe 60 or 70 times before we can reclaim our UAF pointer. During that time, the window rapidly closes on our read, and if it gets past where it reads the data and it gets out of that window, you're done. You're out of the window. Even if you corrupt it, it's too late. The data's already been read. And right now, it means you have to reboot because there's no way to run the race more than once. So that's what Teamstar and I were working out. How do we run the race more than once? So I'll get to that in a second. I do want to check on chat, though, because I know I was kind of going through that process, and I might have missed some things in chat, so let's see. Doesn't Sony have a program where they sell you a dev kit at normal price for research? If not, that you can make a company and buy one for development. Yeah, they do have the DevNet program. You do have to have credibility as a game developer or a game publisher to be able to buy those. They do, from what I know, they do some background checks. Like if you don't have any games under your belt that you can show that you've made or any projects like that, they're not going to sell you a dev kit. That's as far as I understand it. You could maybe try to like fake that information, but then you're getting into questionable legal ground there too, because I don't know what contracts and stuff are involved with that. And there are absolutely contracts involved. If they did have a program like that, you probably would have to report everything to them first. Yeah, that is the other thing with those dev kits. When you buy them officially, like they do have a like an activator or whatever that you have to connect to, and I know it gets a bit weird around that too. And getting under one of those NDAs is not great. Yeah, it would be a problem, I think, especially for like the toolchain and homebrew work that I do. I could see them going after that if I had a dev kit, like an officially registered dev kit with them or something. It's a bad position, legally speaking. I guess it doesn't matter as much for hacking PS4 versus iPhone, but yeah, likely you can't drop an exploit for latest until it's patched. Yeah, I mean, you'd definitely be unhappy if you dropped an ODay that you discovered using their dev kits. They'd probably be pretty upset. They give you some nice money. Same for Apple. No, if you get a DevFuse VR phone, you don't have a choice unless you want Apple to sue you. Oh yeah, I can imagine Apple is probably really, really bad with that. That's even if you that's if you even get a like an Apple VR device. From what I've heard, they're like so hard to get that like nobody can get them. I think who was it? Uh damn it. I tweeted about it a little while ago because it was surprising to me. Let me see if I can find it because I forget who it was for some reason. Um, wow, I've been tweeting a lot lately, huh? Let's see if I can find it. Wow, I can't find it at all. I think it was Sparky, but I might be wrong on that. But anyway, like it seems like it's really hard to get those developer devices. Like Apple is really stingy with them, from what I've seen from the outside. Yeah, the contract they make you sign says you're not allowed to use it for exploiting or reversing. Oh, is that for the dev kits for Sony? I'm not surprised actually that they would explicitly forbid you from using it for that. I wonder what the legal enforceability would be of that. I wouldn't want to challenge it. I'll say that right now. I wouldn't want to go in a legal battle with somebody like Sony, but it would be interesting to see if it did go to court, how that kind of argument would hold up. Like if that would be enforceable. Um, but I don't have the capital to test that, so I'll leave that for somebody else to try. I've been offered kind of informally, but turned it down because I don't want those restrictions, and I mostly focus on the browser as is. Yeah, I don't think I'd want to be under Apple's thumb either. have them be able to dictate what I can and can't do with like my research. That would be really frustrating. In general, before you get access at all, you have to sign it. Yeah, but like depending on the court and like the jurisdiction, even if you sign a contract, it's not necessarily enforceable. Like, I'm not a lawyer here. I'll say that, I'll give the mandatory preliminary thing to say that I'm not a lawyer, but I know there are certain circumstances where, like, if a judge determines that it's an unreasonable condition to enforce, then it might not hold up. That said, the past challenges when it comes to console, like with GeoHot, exactly, have not been particularly encouraging in that respect. Say it's not illegal advice. Okay, it's not illegal advice. How does Erno get updated in that last for loop? So the Erno gets set by the ioctl wrapper. The ioctl wrapper in userland, when it calls the syscall, it has code in the FreeBSD libc that'll set Erno and everything appropriately. I zero Erno out every time before I read it, especially on anything PS4 related, because Erno's really annoying. It'll get smashed by other things, and if you read it without zeroing it first, it probably has a stale value. Did you see my question? I might have missed it. If I did, I apologize. I can try to scroll up and find it. Looks like low-level stuff. Does it coalesce? Is that the question you're referring to? What do you mean, does it coalesce? Can you elaborate a bit more on that, and then I can give you an answer. It would be nice to get it up to 90% stable. That would be ideal, yeah. Alright, so I will get into what Teamstar and I were working out. So, essentially, what happens when you get to this state, right? So, the way we manage the overlap and are able to trigger the double free is we have two UDP sockets that share the same mbuff, right? So, by freeing the first UDP socket of the overlap pair, you can get that assigned to something. And then by freeing the second overlap socket, you can get that assigned to something. And that's how you can set up the controlled UAF. Problem is, once this thread runs, you've exhausted your first overlap right here, because it's going to be given to a write FD. Over here, you've exhausted your second overlap, because it's going to get reclaimed by your spray, your heap spray. But you can steal those back, because once they're back in the free list, they will get released again. Whenever you read these packets back out, they're going to get freed. So one of these is going to have the overlap again. And then over here, when the read FD finishes off, that's going to be popped out of the message queue for that TCP socket pair. And then that will be released back to the free list, and we can reclaim it with this spray, actually. So by increasing the spray size, we should be able to reclaim both this overlap mbuff and this overlap mbuff. We should be able to retrieve both references. Now, something we have to account for there is the way we initially detect which sockets have the overlap is we do a tagged spray. So let's go up here. So here we trigger the double free, and then we do a tagged spray. So we spray the index in a for loop, and then we check if the index doesn't match up with what's supposed to be there to detect the overlap. We can't really do that here necessarily, because we're not spraying an index, we're spraying like a packet that contains pointers that we want to use, and we can't like make that point to tag data or something, because we want that data to be used if we can successfully hit the race, right? We don't want to give that up, because that wouldn't make sense. You're getting your priorities backwards if you do it that way. I think the way we can get around that is we can do some tagging on the pointers themselves. So right now, I just spray the same pointer in every loop iteration. I spray this spray packet pointer, which is just a userland pointer that I have set up. Right at the top of main, I malloc it. What I would have to do is I would have to make those pointers into tags. That way I can spray those tags, and then I can check the pointers afterwards. Now, they still point to the data that we want to use to corrupt, but we can use the pointers themselves as tags, sort of, right? So now that we have that, we can detect where we have the overlap, and then we just, like, rerun it. We rerun the exact same scenario, and we keep doing that until hopefully it works. Now, in theory, that will increase your success rate because you're brute forcing it until it works. In practice, more likely, the more often that you try this race and fail, the more likely the system's going to blow up. Because depending on what's going on the system, you might not always be able to reclaim that UAF pointer. If something else steals it, you might not be able to get it back. Or it might write something there that screws up what you're trying to do and you know, panics the system. So ideally, like, if this could hit it on the first loop, that'd be great. If it could hit it on the second loop, then that would be good. But the longer that loop goes on, the more likely that we're going to need a reboot. But that's probably better than relying on a one-shot, like a one straight shot, and if it doesn't work, have to reboot anyway, right? The more chances we can give ourselves, the better. So, yeah, that's what I'm going to work on. Teamstar also did have a way we could try to improve the first point of stability I mentioned earlier, which was spraying trying to get an overlap. Sometimes when we trigger the double free and we spray a bunch of packets and try to get an overlap, we don't get it because something else steals the pointer away. Now, usually, like, that's not really fatal most of the time. But we could potentially improve the stability of that by doing a little bit of, like, heap feng shui by, you know, pushing a bunch of stuff, a bunch of packets, and then freeing them all, and then trying to get one of those free pointers. Make it more likely so we get both, basically. That said, that's probably not something I'm gonna put too much, like, it's not something I'm going to focus on right away because, like I said, that point of failure is a lot less annoying. It just requires rerunning the exploit. The second way of failing is when you get the system. You have to reboot, which is much less convenient. All right. So we'll start off with increasing the spray size. So I have this set in a macro. So let's go ahead and... I'm actually going to make a new macro because I don't need to increase the spray sizes of the previous sprays that I do, just the one for the race. So I'll do define spray. How do I want to title this? I guess we'll do spray socket corrupt num. Right? X500 is probably sufficient to be able to reclaim it. Just want to align these because right now they're all over the place. Yeah, hex 500 I think would probably be sufficient. It's probably a little bit overzealous, honestly. It's probably too much, but it should be fine. Like, shouldn't be a problem with going overboard. So yeah, we'll change that. We'll go into our other thread here and change that. The other thing we need to do is now tag the pointers. And this is going to be a little bit more annoying. It's not going to be really annoying working with a C program that we're running right now. This will be annoying when we take it to WebKit, because I like to implement the kernel exploits in WebKit in hand-coded ROP chains. Whereas, like, Clearscovy and I know some other people, they like to run their C payloads through a ROP chain compiler, which works, and it's a little bit more maintainable, I guess, because you can just edit the C and then recompile it. But you are adding a lot of stuff on WebKit doing that, you're adding source files that are like 200, 300,000 lines of code. And when you're dealing with WebKit exploits, depending on how the WebKit exploit taints the state, you could end up with a situation where just adding too many lines of code will just cause WebKit to crash because you've already done so much damage to the WebKit heap. I remember there was one WebKit exploit I wrote where I permanently broke the garbage collector, so I had to be like super careful what I did with the exploit itself, because if I did too much and triggered the garbage collector to run, it was death. It was death to the browser. So some interesting challenges come up when you're dealing with WebKit and trying to run a privesc from WebKit if you don't have like JIT or something. If we had JIT, this wouldn't even be an issue, but we don't, because Sony doesn't like fun. So it's ROP chains all the way. My life is just heap grooming and code reading. I need to get better with heap grooming. It's something I've done and I know like the basics of, but there's tricks that I wish I knew better. Like Teamstar was telling me a few things that we could try to do with heap grooming to improve it, and I know it's something he's kind of been forced to deal with his iOS stuff. So yeah, I need to try to like get better with that, because it would help a lot for like any exploits that I'm working on. By the way, Spectre, do you think it will be possible to make good PSP emulator on the PS4 OS? Probably not, because the PS4 hardware is not that good, guys. It's really not that good. You're talking about an 8-core CPU at 1.6 gigahertz. When you try to emulate instruction sets that you don't have hardware support for, your performance is gonna suck. If I remember right, the PSP ran on... Was the PSP MIPS or was it PPC? I don't remember what it was. Either way, though, the PS4 is not going to have... I don't think it has a native... like a native emulator. Like a piece of hardware dedicated to doing that. MIPS? Okay. You know what? I know the PS4 can run PS2 games. Like, that's not officially supported. It can do it if you have a jailbreak. So maybe it would be possible on the PSP, because the PSP and the PS2 are both running MIPS from what you guys are saying in chat. Okay, PSP. Yeah, I know the PS3 was PPC. I thought the PSP and the PS3 came out around the same time though, so that's why I was kind of wondering if the PSP was also MIPS. But you know what? I'll kind of revise that stance then. If the PSP was MIPS, then maybe you could do some emulation on the PS4, because, like I said, you can run PS2 games. So it might be worth a shot. That said, I don't know a ton about PSP internals. So, you know who would be one to ask about that, actually? I think Flo would probably be a better one to ask. I think he did some stuff with PSP. Flo might have a better, like, insight into that. You can run them really bad, not every game. Little games supported. Yeah, I know PS2 games are really, like, that's why they aren't officially supported. The support is really shaky. I know people have to mess around with, like, settings a lot to try to get some games to run. Some games just won't run regardless. PS2 has 2 MIPS and 1 SPC or ARM CPU. Oh, I didn't know the PS2 was that interesting from a hardware perspective. How to talk to the Flow. I have the Flow added on a few places, but I don't want to bug him too much. He's busy, man. He's a machine. He's diving deep into networking stuff. if you see what he's been doing with Project Zero and their fuzzing stuff, like he did some work on packet injection with syscaller as well for fuzzing the networking stack in kernel. Message flow on Twitter if you're not blocked. I don't know if he has DMs open, so I'm not actually sure. I don't think I've checked. Bluetooth stack, yeah, yeah. Flo is doing quite a bit with the Bluetooth stack on Linux, on BSD and XNU and PS4. He was looking at the IP6 stuff. I don't know if he's still looking there. That was like last year, so he's probably moved on to something else. But that guy, I don't think that guy ever sleeps. He's a machine on VR. I wish I was like as enthusiastic about VR as Andy is. All right, so let's tag the packets. So what I will do is let's keep a global array that holds the spray packets, and we're gonna make that the same size as what we had for the spray socket corrupt num. So that'll be corrupt num like that. Oh, actually, int is not what we want. We want a uint64t array, right? We have an array of pointers. All right, so we have this array, and instead of just allocating one spray packet, we're going to allocate many spray packets. So we'll do a for loop here. 0 is less than spray socket. Let me get rid of this for a sec. Spray socket corrupt num. And in here, let me just get this here so I have it. Yeah, instead of spray packet, we're going to do spray packets I equals the malloc call here. I think I will set this up before I set up the spray sockets, the fake file object that is. And then wait, what is going on here? How did this not break? Okay, that's weird. I don't know what happened here. So we need to set up the spray packet so that the padding is set to 0, so that we account for that 4-byte shift that I mentioned earlier. And then we also need to initialize the full stack of fake file pointers. So this is going to be spray packets I pointers. Oh, this has to be, we'll change this to J. So spray packet I pointers J equals fake file. We only need to set up one fake file object because we'll just make all the pointers point to the one we have set up. We don't need to set up multiple fakes for that. This should be good, I think, for setting up the tagged pointers. This we don't need anymore. That was kind of a remnant. These are all remnants, actually. Let's get rid of all that. Code is a little bit messy right now. Excuse it. It is the typical, like, crappy, bad exploit code. I do like to try to clean it up, but where there's been so much movement and I've been trying different things, I just haven't bothered cleaning it up yet. Right now it is kind of horrendous, though, at certain points, so forgive me for some of the bad code that you have to witness. All right, so spray UDP sockets, spray TCP socket pairs, this is all fine. Yeah, this looks good. So basically, now we're gonna change in the thread, in the other thread that runs. Instead of making it use this loop, we're gonna make it use a slightly different loop. So actually, loop itself will be the same, but inside of it, we're gonna push to UDP socks I. We're going to push the spray packets J, which means we need another for loop here. Actually, no, we don't. We're going to use the same indexer because we set up an equal number of spray packets to actually, no, we didn't set up the same number of UDP sockets. I'll have to fix this. We'll need the same amount of UDP sockets as spray packets, but I'll fix that in a minute. So yeah, we have that, and then we just need to do size of spray packets 0. Right, and that's all the arguments. So now we're doing effectively the same thing we did before, but we're doing it with different pointers every time. That way we have a tag set up that's embedded in the pointer itself, right? You ever think of doing pwn to own? I've thought about it for sure. It is very like enticing. Like when we've covered on our podcast a few times, like pwn to own results and stuff. It does seem like it's been kind of losing prestige a little bit. I remember like a year or two ago, even like not that long ago, where there was a lot of like browser stuff and kernel stuff and mobile stuff all coming out of it. But like last year, when there were like 2 or 3 pwn to owns that we looked at, it was almost all like routers and like IoT stuff. I was like, oh, that's not as fun. It seemed like there was a lot less browsers. Like I think actually one competition, I don't even think there was any like browser stuff submitted or anything, even though it was in the list of target applications. It just seems like people don't want to burn their browser bugs there anymore. They keep them or sell them elsewhere and just take the easy IoT targets. Tianfu Cup got most of the browser stuff. Yeah, they had a lot, and they had mobile stuff too. If I remember correctly, like iOS and Android. I think part of it was when China, like Chinese teams got banned from participating in pwn to own. I think it took like a big hit in terms of the competition. Because it seems like now everyone just goes for the IoT targets. They're like, why go for browser when we can just go for these easy things that can give us free points? So I hope the future ones we get to see more browser stuff, because that's always fun to look at. There's browser exploits going this year. The trick is to use your worst bugs. Yeah, I've heard that. People will use the ones that are like, there's no way they would ever be useful because they're too unreliable or take too long to run. The ones that take like 5 minutes to run. I guess those would be like ref count leaks or something, probably. Something like that. I've dabbled a little bit in browser exploitation. I've never found a browser Ode. That is over my head. Partially because I really dislike auditing C++, and I dislike C++ in general. But I remember when I took like Ian, was it Ian Beers or was it? No, I don't think it was. But yeah, I took an end day from Google Project Zero in like the end of, or the in 2019 at some point, and took like the crash report and made it into an exploit, and it was really fun. I really enjoy browser exploitation on the exploit dev aspect, but I really do not like reading browser code. I mean, have you spent much time looking for browser ODs though? I haven't spent much time, and it's because like C++ just, I hate all the levels of indirection you have to deal with. I like auditing that code base looks like a nightmare. Which I mean, I guess is why there's so many bugs there too, but I think it would get way too frustrating for me. Browsers are my bread and butter. You get used to it. Yeah, I guess. Yeah, when you put it like a lot of time in, and if you're able to cut through the C++ barrier, I guess it can be very fun. Yeah, but like, it's just C++ is like one of the things I just really don't like reading. That's why I stuck to kernels. Kernels love C. They hate C++. Although unfortunately Linux kernel is showing some love for Rust, so see how long that continues to remain true with loving C. But yeah, like I don't have to deal with all that, like all those levels of indirection and all that stuff. One interesting thing I've seen, like, or noticed with browsers. Now, obviously, I'm on the outside. I don't do browser research, so maybe this is just like a recency bias or something. It seems like a lot of the browser stuff I've seen in the last year has all been in WebAssembly or like JIT optimization. I don't remember the last time I've seen a bug that was in like DOM or like JavaScript core, especially JavaScript core. And it sucks because I like to look for like endays that could be used on the PS4, and the PS4 doesn't have WebASM or JIT. So those bugs are just out the window. They're not viable out the gate. Um, it seems I guess JavaScript core and DOM have just been so picked over the years between like Project Zero and everyone else that it's just like only the really, really, really complex areas are left, I guess. Um, and I mean, it's because the JIT is so complicated. Yeah, I remember Z and I tried to cover a JIT optimization based bug, and we were really struggling. We were struggle bussing to try to like even understand the basics of the issue because it was so convoluted. There have been a few, but there are less you see in JSC nowadays, and also the DOM has ISO heaps. Oh, I isolated heaps. Was that with like the what's it called, the GigaCage allocator, or was that something else? Am I confusing GigaCage with I can't remember. That's another thing that's interesting on PS4 too, is I don't think it has as many of the heat mitigations. Like I don't think PS4 has GigaCage, or at least it didn't. It might now because they did do a big leap in WebKit version. Yeah, in my training, there's like 6 hours of stuff to even get to exploits. I can imagine the amount of background info is insane. The ISO heaps came at the same time but are different. Oh, okay, so GigaCage is kind of like adjacent to it, but it's not the same thing. Dude, browsers are so hard to get your head around. Uh, LM wants me to see your message. Where did you send your message? Did you send it in chat? I don't see it. If you did, where did you send it, LM? You're probably gonna have to send it again. I might have lost it in the void. Sorry, dude. It was a big surprise when they updated libs in 7.02. Yeah, they've been doing some movement on the PS4 in the last couple firmwares. Um, I noticed the big WebKit jump in 6.20. They have this new library called like libwebkit.nk. I don't know what the hell it is. It's something weird. Like they have WebKit split into two binaries now, and I don't know if that's WebKit or if that's Sony that did that. Um, and I had to completely change the code execution strategy on 6.20. What QWERTY used to do and what we used to do for like the previous WebKit exploits was he would just leak parse floats function pointer, and we would like overwrite that to kickstart ROP chains. I don't know why, but that didn't work on 6.20. I had to change it to a vtable smash. I did a text area vtable smash. I leaked a text area vtable or a text area object and smashed the scroll left pointer in the vtable. But I don't know what they changed to make it so that the parse float leak didn't work anymore. Like you would still leak a pointer, but it wasn't a function pointer anymore. It was a pointer to some other object. I don't know what it was. I never really investigated too far, so I was just because of my lack of like knowledge of internals of WebKit. I was just like, screw it, I'll just do a different strategy. But still, to this day, I don't know exactly what you leak anymore when you try to leak a parse float. It's not a JS function anymore, whatever it is. Oh, the Ret2IO trainings. Yeah, I love the talk you guys did, by the way. Um, for zero day engineering. I think I linked it actually like a couple streams ago. People were wondering about how to get into like vuln research and stuff, and like that talk is really inspirational. For some reason, I can't remember the exact name of the talk. It's the 0-day methodology, was it? I don't know why my memory sucks so bad, but yeah, it was an awesome talk. I loved it. Do you think your exploit is going to be much more stable than Sir's Gobi and with that much kernel panic? It's hard to say, partially because I've never actually even ran Sir's Gobi's exploit, because I don't have a PS4 and 7.5. So the only, like, you can't really assess stability too much until you've ported it and implemented it, because it's very tied to system state. If there's a lot happening on the free list, this will lose stability. If there's not a lot happening on the free list, the stability will be better. If the CPU is slower, which it is on the PS4, in theory, this should be more stable because it's doing a race between, like, interleaving between threads, and the IPC should be lower on the PS4 CPU. So the interleaving should be easier to do. But that's all theory in my head. When it actually runs on the system, there's factors that you can't really account for in your head when you're getting into like races and stuff like that. Layman's Guide to 0-day engineering. Yeah, yeah, that sounds about right. Yeah, there we go. Z got it. All right, so we have tagged pointers that we are pushing into the overlapped sockets. Now what we need to do afterwards is basically loop through those and check if we have ones that overlap. So what we're going to do is, after we do that, we'll do another for loop. We'll just copy this. But instead of pushing, we're going to peek. And I'll copy that from somewhere else, that way I don't have to rewrite the peeking code. Yeah, basically right here. So let me think about this for a sec. We're spraying into the M-bus a stack of pointer. You know what, actually? I hadn't really thought about it. We could actually tag without using the pointers. Because we have 4 bytes of padding to account for the shift, or the alignment for the file pointers. We could actually use that little 4 bytes of padding as a tag. That might be easier, actually. That way I don't have to, like, track the pointers or anything. You know what? I'm going to back this up with the changes, but I think that's what I'm going to do. That'll be an easier strategy, I think. So I did that work with changing, like, to embed the tags in the pointers, but I'm not even going to do that. This way, it's not going to make a big difference on the C side, but I'm thinking ahead a little bit. When I have to port this to WebKit, not having to do it this way will be a little bit nicer. So yeah, we're going to change this. We're going to undo all of that. We don't need that the way it was. Put that back. Right, okay, this does need to change, though. This does need to be the spray socket. Corrupt num. Do we have spray packet, or did that get lost? Nope, it's still there. Struct overlaps spray packet. So basically, if you take a look at the structure that we're spraying, we have these 4 bytes of padding, which I use to align to the hex 10 byte boundary. That's also why I have to use the packed attribute. If I don't have this set on the structure, like if I just took that out, what would happen is because this is an array of pointers, and pointers are always supposed to be aligned on an 8-byte boundary and on x64, there would actually be 4 bytes of padding put in between these two field members. So you'd have 8 bytes and then the array of pointers. Because I'm specifically trying to align these pointers myself, I have to pack the structure so that this starts at 4 bytes in instead of 8 bytes in. But these 4 bytes of padding, I can do whatever I want with them. Right now, I just keep them at 0 because I didn't care. But what I'm going to actually change this to is I'm going to change that to a tag. So we'll change pad 1 to tag. And then instead of initializing it to 0, we can keep it initializing to 0 here, but then in the loop in the second thread, we will change that in each loop iteration. In theory, it will make the race, it will add instructions that have to run in our race window. That said, assigning a 0 or assigning like a 4-byte integer is going to be literally like one instruction. So it's not going to kill us. So yeah, in our loop, in here, instead of like doing that weird stuff with trying to keep a 1-to-1 ratio with our like number of spray packets and all that stuff, we'll just do spray packet tag equals I. Now we have which index that spray packet is. And then when we try to check for where we have our overlap, we can just check the tag. So let me just get this on another window so I can access it easily. And then what I'm going to do is in here, instead of pushing new mbuffs, I'm going to peek them. So I'm going to peek mbuff UDP slots I char star, and we'll have rest v packet, I guess. We'll set up a different packet for that. Although actually, once we spray the packet, we don't need it anymore. Actually, we do. Because when we rerun it, it'll be easier if we just, yeah. So what I'll do is I'll set up, we'll keep the spray packet, and then I'll make another, we'll call it check or tag packet. Or rest v packet. That'll be a little bit more descriptive. So yeah, when we receive, instead of receiving into spray packet, we'll receive into rest v packet. Struct overlap. And yep. Right, so we have the peak set up, and then we will just check if rest v packet 0 does not equal I. Overlap 1 equals I. Overlap 2 is, in theory, it should be whatever we read there, I think. So it should be rest v packet 0. Or sorry, rest v packet tag. Because we have a structure set up. It's not an array of integers like I used for the original tags. So this has to change too. This has to be tag. Right. So what we're doing here is we're trying to reclaim everything, including the pointers that we might have lost. So we're reclaiming all those pointers, and then once we've done that, assuming the race has failed and we didn't hit the corruption that we wanted, it will fall back on reading through all of those packets that we pushed and checking, do we have an overlap again? And then once we have that overlap, we can just run the same race again, essentially. Now, kind of like that, kind of like what I said earlier, I do have to modify this. Right now, UDP socks is only 100 or 256. Where I'm increasing the spray size for this one, I am going to have to use a different set of UDP sockets, actually. or just increase the amount I use here, which is probably what I'll do. So we create our UDP loopback sockets here. So instead of doing it for spray socket num, I'll do spray socket corrupt num. That's going to create more sockets for us to work with. Anywhere else, though, we'll just use the lower amount where we don't need as many. And we'll just leave the other ones unused. It's not a big deal. So, yep, this should be fine, I think. So now we've tackled the spray size. We've got the overlap. Now we just need to work in the code that'll make it rerun if we get to this point. So I'll work on that next. All right, let's see what's been going on in chat. Unregistered Sublime text. Yeah, I mean, I know Sublime text is super easy to crack. It's got like no protection or anything. It doesn't really bother me though. I don't mind the pop-up. Like the pop-up comes up every 50 saves or whatever. It's become so automatic for me to just close it or ignore it that I just don't care to register it, honestly. Or I don't care to crack it or whatever. I just leave it as it is. Can't you tag it earlier? Like tag it outside of the for loop? No, because I'm just using one spray packet. So I would have to tag it as I go. LM, sorry, I did almost miss your thing you wanted to ask. I just caught that, so let me check. You wanted to ask what I think of libjbc. So yeah, I saw Slirsgovy publish this firmware agnostic implementation of Sandbox Escape. It operates by traversing the process list and copying its prison and ardor into the calling process. Okay. That's pretty cool. Yeah, I mean, it seems neat. Generally speaking, I don't really support homebrew apps that want to escape the sandbox unless they need to. Because the way the sandbox is set up, like, it's mounted for you to make things easier, too. It's not just security. Like, they also do it to make it so that you can access your assets, right? It mounts app 0 into the sandbox. I don't understand why people want to escape the sandbox unless they absolutely need, like if they're an FTP application or something where they want to operate outside the sandbox, then it makes sense. If you're just like a game homebrew or something, you don't need to escape the sandbox. And that's kind of why like Kiwi kind of feels the same way I do, and that's why we haven't had that functionality exposed and like advertised in Mira, because generally speaking, like homebrew, you only want it to have as much access as it needs to. Like people who go overzealous on their access from homebrew applications, that's how you end up with people doing dumb shit, like writing something that could brick people's systems or something, right? Even like just by accident, right? They try to mess with something and they're like, "Oh, I tried to write to the registry and I was off by 1 index. Oh shit!" Like, yeah. So I try to keep sandboxing in place by default, and people should only escape it in homebrew applications if they really, really need to for some reason. Yeah, I have a Python script that would do it. The real fun is removing the registered text. They XOR it to make it harder to find, but you can just look for the XOR operations. That's pretty funny. I haven't really looked at Sublime Text. Yeah, like a disassembly view. I don't use it, but I've cracked it for a friend in the past. More fun to crack stuff that isn't FlexNet. My problem is when the pop-up is open, it can lose focus and then certain keyboard ops break. Oh, that is a fair point. Yeah, I've noticed that too. I guess where I don't use keyboard shortcuts as much, like I use the mouse a lot more than people like. People have teased me about it before, where I use the mouse for doing certain things where they're like, why don't you just use the keyboard shortcut? So that's probably why it doesn't affect me as much. My store app definitely needs a jailbreak. Yeah, I mean, there's certain applications that definitely do. Like, I could see why they would want to break out of the sandbox. It's just one of those things where I think a lot of people do it just for the sake of doing it, and they don't have a good reason to. Why don't you just use Nano is the real question. So, the Nano I have on BSD is nerfed. It's sacrilegious what they've done. Look at what they've done. I can't do line numbers because it's so old. It's Nano 2.2.6. And I can't build newer Nanos because the repositories and everything are down for FreeBSD 9 and the dependencies are down. So my Nano is like really nerfed on BSD. It's really sad. Flats, welcome in. Good to see you here. Yeah, though, getting back to the exploit, this should be... Oh, I do have to implement the code to, like, the harness to rerun the race. So let's do that now. Once we have overlap 1 and overlap 2, we can... So what I'll do is I'll set up another variable, rerun. So rerun at the top of main will be set to 0. And then we will rework our race portion, which is down... yeah, I guess this point here. We'll put this into a for loop. We'll make it an infinite loop. For now, we'll break out of it later. And then we'll do a while, oh yeah, I had that in my clipboard, didn't I? While rerun does not equal 1, we'll just sit here, busy wait. So basically what this will do is it'll try to run the race, and then it'll wait on that thread until we specify a rerun, which will be specified from thread 2. Thread 2 will set rerun to 1, and it will run this again, essentially. Yeah, I think that that makes sense. And then in thread 2, I'll be hacky. I'll use a goto. So here, when we get to this point, we're gonna do a start. We're gonna set start thread to 0 again, so that the main thread can kick off the race, and then we'll go to rerun, and this will be rerun. This should be fine, I think, because I don't declare any new variables, right? No new variable declarations in the loop or in the label. I don't think so. I think we're fine. All right. I will upload this to see inevitably what I've fucked up, because I know I have errors somewhere. It's bound to happen. So let's go back in. Oh, let me increase the font size. I know it is really small for you guys. Sorry. Got to change that first. Okay. In function. Whoa. Wow. I didn't get any errors. I think this means I've reached a new level of programming. What the hell? I can't believe that shit. That never happens to me. Let me just make sure I uploaded the file. Oh, wait. Oh, I do have an error. Okay. I'm blind. Sorry. Invalid application of size of to incomplete type struct. Oh, it was a typo. Of course. I was so close, dude. Oh, man. So close. Okay, it's fine. It happens. Now it's all warnings. No errors. So that's pretty awesome. I was so close to being able to say that I reached the next level, but I guess I didn't. Yeah, so no errors. I do have some warnings. They're like, because I don't do casting, I don't really care enough to go fix them at the moment. I could specify where, yeah. and make my life more fun. But I have to deal with that when I'm compiling the kernel, though. So for those who don't know, I do modify the FreeBSD kernel. I have the source installed, and I can make install it, and then reboot. And I do that for debugging, so I can see when certain routines are running relative to each other to try to get the interleaving to work. And the FreeBSD kernel build does have where set on it, so like I'll just run a hack, or I'll just write a hacky line to try to get a log, like %lx to try to print out an integer, and it's like, this is not an integer, it expects an unsigned long, and it's like, oh man, fine. It's like so pedantic and annoying. I could probably go into the build files and fix it, but it's easier to just do the cast. I have a bad habit of refactoring exploit code until it starts to look clean. I do that too, actually. I do like to refactor exploit code. I've refrained from doing that though, because I've been changing stuff so much. I will run a pass on it though, to like clean it up for sure. Because I'm not really happy with how it looks at the moment. There's a lot of, like, if I put this down and came back to it in like a couple weeks, I'd be like, wait, what? Why did I do this? Why is this here? So it definitely needs a cleanup pass. Yeah, I guess we can give this a try and see if it works. Like, if the exploit fails, if it'll rerun on its own. I think it should, the way we have it set up. Let me just make sure I don't have any infinite loop hangs or stalls. Let me just make sure. So here we start the thread. We delay, run the race. This is old. Let me get rid of this. That's for something I was trying that didn't work out. Potential RIP hijack. The IOCL call. IOCL call runs, and then failed, waiting for rerun. I don't even need this anymore either, because I was testing. Rerun will be set to 0 until it's set by 1 in the other thread. Let me get the other thread in a split view, actually, so I can compare them better. All right. So let's get rid of that. That's not really fair. That's not relevant. Okay. So the corruption thread, it runs. It waits here until it's ready to start from here. Frees the mbuff, sprays, sets up the tags. If it fails, yeah, this is fine, because essentially what I do here is, oh, I did forget to set something up. I do forget to set rerun to 1. Good thing I caught that. This would have never executed if I didn't catch that. Okay. So yeah, we rerun, and then we go to the label, and then we wait for the process to start again. Okay, cool. Oh, I do have to add this in the actual code, because that was just my split view. Okay, that should be good, I think. Let's give it a try. See what I messed up. So I think, yeah, we should be in a clean state. So let's go ahead and run it. I will get a log run. Oh, I will get a log running, so we can see what happens, and we'll run the exploit. So this is our tag spray that's happening right now. Oh, overlap failed. Okay, we'll run it again. Okay, found the overlap. Now we're doing the race. Well, it looks like I think it succeeded. I didn't get, my terminal was covering the FreeBSD VM, but usually when it crashes in that way, it means we got code execution with the 4 ones. I'll be able to check in a second with the core dump. that is the unfortunate thing with running like the BSD in a VM. Some people might wonder, like I think somebody's brought it up before, why are you SSHing into the VM when your exploit deals with like the networking stack and you don't want interference? The reason is because working with the VM directly is really horrible, because I can't install VMware tools to make it less horrible. So I can't scroll up or anything like that. It's really shitty. So that's why I use SSH so much. Oh yeah, I do have to increase the size of this terminal as well. Do that first. Okay. So our crash ID was 11, so we'll do crash core.text.11. Oh, this isn't actually... No, we didn't succeed in code execution. This was one of the rare events where we lost the pointer that we had a UAF on. Something else took it. Because userland crashed, and it triggered that SB flush internal panic. Okay, that's less cool, but oh well, happens. Let's get a log running again, and we'll run it again. Not much we can do to prevent that, to be fair. That's kind of hard to control on our side. You should disable DNS on FreeBSD SSH so it will boot faster. Does DNS really slow it down to that degree? Shit. Thanks for the tip, Flats. I'll look into doing that. Okay. So we crashed in userland again. Not quite sure why. This is bad because the kernel is now hung. You'll be able to... Oh, we can't... It's actually not fully hung, but the process is hung. Right? We can't get out of it. I'm going to reboot the VM and take a look at that core dump, actually, to see why userland crashed. Because that might be a result of our new changes. That might be an issue. Can't you use virtual serial? I could. I just haven't bothered really going through and setting it up. Because, I mean, I could use a serial for the logging, but I would still have to use the SSH to... Well, no, I guess I could run a terminal over serial too for the other stuff. I just haven't really bothered to do the serial stuff, to be honest. Because it is a little bit annoying to set up. Let's see what the core dump was. Should be able to get that. All right. So I think I should be able to pull into here. And let me open up a terminal in the directory where I pulled the core dump. We should be able to do GDB. Oh, I don't have GDB? Holy shit. I guess that shows how fresh my install is on WSL. I can't believe I don't have GDB. That's that's a very fresh install of WSL. Hey man, what's up? Hey Seville, welcome in, dude. Welcome back. GDB. Yeah, I'm just gonna use GDB to look at the core dump. To be honest, I don't really do like a lot of core and like core dump analysis, so I love print debugging. That's the best way of debugging. Yeah, use printf. I could do that. I might do that, honestly. I just want to take a look at the core dump to see if it has anything interesting. Oh, actually, yeah. I guess where it's fuck it. I'll just do print debugging. It's whatever. Was arguing with as if all this day. How was your day so far? Did your strategy work? Our strategy does work. We have code execution. I showed a screenshot on Twitter earlier, but yeah, we got instruction pointer 4.1. So we do have it working. We're just trying to increase stability a little bit. Okay, so where did it fail here? It was after we found the corruptible mbuff. Right? Okay. The nano sleep wouldn't be crashing. Ooh. Print debugging could work, but I don't really want to insert prints in here because this is the race window. I don't really want to add noise. Whatever. A print probably won't be too bad. Actually, I'll take this loop down a little bit to like 300. That should hopefully give the print space. Reading FDs. Then, well, we'll get this print afterwards. So, yeah, it's probably the read FD that's failing, to be honest with you. And the reason that's probably crashing is the way readfd works is it issues a control message to like an SCM writes control message to try to get those file descriptors we set up. If the race failed in a certain way and makes it so the receive message fails, it won't be able to parse the C message sections. Although I make it check if it's under 0, so that should be fine. Yeah, actually, I'm not sure why exactly it would be crashing in there, because it should be caught by here. The receive message should fail if that's the case, and then it should return early, but it's not, it would seem. Why does Discord show that Z is the one doing the stream? Discord just, the way it detects that is if you have your account linked to your Twitch account and your Discord account linked. So because both Z and I have the Day Zero account linked to our Discord, if either one of us is streaming to the account, it'll go on both of our like users or whatever. It's similar when Z streams the podcast. It'll show up on mine even though I'm technically not streaming. Yeah, I'm not sure why this would fail the way it does. I'm gonna check actually. I'm gonna check the kernel log to see if I can identify why that happened. Because it shouldn't be. It should be getting caught. Okay, what's happening? So we have a double free on this mbuff most likely. Yep, right here we can see 2 clusters grab the same pointer. Internalize takes it. And then when internalize takes it. And then when it gets to externalize, it uses a different mbuff. Or no, wait, sorry, no, it uses the C message data, that's correct. Yeah, so it takes this mbuff for the UNP internalize, it'll put the data in C message data, which is here, and then this pointer is used by UNP externalize. So these are all valid file pointers. Do any of them get corrupted? Nope, they all look fine. That's interesting. Maybe it is something in the code we wrote to try to rerun the race. Because if it happened in thread 2 after this, then that would make sense. So let's just do a quick, we'll do a printf, reclaim finished. If we're here, we might have lost. I don't think I'll put it in every leak or every for loop iteration, but if we do find an overlap, I will print that out actually. So let's do printf found new overlap. I equals %b. tag equals %d. So we'll do I and overlap 2. Actually, we'll do overlap 1 and overlap 2. Make it a bit more clear what's going on. All right. We'll add that in there, and we'll be able to get better information now. All right, let's get the kernel log and run it again. Okay, it's crashing on the reading FDs portion. Wait a minute, something's fishy here. Yeah, something's wrong. Usually there's clusters being sprayed in here that are trying to interleave with the externalize, but that's not happening. So there's something problematic happening there. So let's see, what changes did I make? I ran start thread. I started the read FDs. Thread 2 should be running. It should get past this point, and then it should be trying to reclaim. The spray packet should be fine as well. That does make sense the way I have it running. Yeah, why am I not seeing my packet showing up in the log? I'm seeing the initial clusters, but I'm not seeing the clusters for the packets I usually expect. Thread 2 does get started, right? Just make sure. Yeah, thread 2 does get started. Just make sure this is the right size. UDP socks. Oh, shit. I'm actually surprised this doesn't crash earlier. I increased the amount of sockets that I spray in main. Like, I open up a lot of sockets. Like, I go up to spray socket corrupt num, which is hex 500, but I only create an array of hex 100 size. I should have had an overflow and a crash before anything even ran. That's pretty incredible that I made it that far without crashing, actually. Alright, I see the issue. I just needed to change that to that. Now we're fine. Alright, I think that was the problem. So yeah, we should be good to restart really quick. Hi, just wanted to join the stream now. How many stream to get it working this way? We have been streaming for a little while. It has taken a bit of time to get this far. This bug has been trickier to exploit than I originally thought it would be. So yeah, it took longer. Teamstar is awake. All right, cool. Teamstar is ready to. He's grabbing a coffee and he'll join in. Is PS4 the only thing you work on? It is not the only thing I work on. Actually, as of late, in the last couple months, before doing these streams, I hadn't really worked on PS4 stuff much at all. I was kind of taking a break from it. A lot of my work on PS4 over the last year or so hasn't been exploitation related at all. It's been all on the toolchain we've been working on. The OpenOrbis PS4 toolchain, which still does not have GPU accelerated rendering, but will one day in 2027 maybe. But yeah, like I work on more than PS4. Yeah, I already answered that. If there is 0 day sec, that means there is first day sec, second day sec, all the way, and so on. Yeah, we're day 0, not 0 day. There are no other days than day 0. So, you know. All right, let's get a fresh log going, and we have to upload my fixed source file here, and we will run it. That should hopefully fix our crash. We'll find out in a minute. Well, I mean, you can access whatever index and day you want. True. Okay, this is more like it. Oh, we still crashed, actually. And actually... Wait, what the wait a minute. Where's our externalized call? What? Okay, apparently we still have a problem. It never reaches the externalized call. But why? Overlap pair +1. This should all be fine. But in reality, it's not. Okay, what happens? Okay, it does read the out FDs. Okay, so it seems we lost the race. The kernel log is really weird. It doesn't show the externalized call. I don't know why. It did happen because I can see the results in userland, but it's not showing it in the log at all. Like there was some messages that got lost here because you can see right here it got truncated. There was supposed to be some messages here and it didn't come through. I don't know why. That's really strange behavior. And then when it tries to rerun the exploit, it blows up. Reclaim finished. If we're here, we might have lost. Right, so... does it maybe not find the receive packet? It is possible that it never finds this overlap. Let's see if we reach the end of the... Reached? Thread 2 exiting. Maybe thread 2 is exiting. That would totally be possible. Right. I do have to reset the state of the rerun after we check it. Okay. We'll see how that works out. I think that should maybe fix the issue we were having. Basically, we were checking if we needed to we were busy waiting until we needed a rerun, and then when we did, like we never reset it. So actually, this should be set at the top of the loop here. We set up here. Yeah, that's the place it should be. All right. Yeah, I think this is a start. All right. We'll see where we're at, I guess, in an attempted rerun. Hopefully shit's not still bugged, but we'll find out. I told you that? Oh, did you mention it in chat and I missed it? If so, I apologize. It is hard to keep up with chat sometimes. Ooh, I think we made it. I think we made it. I think the exploit ran. We'll find out in a sec here, but we shall see in a sec. I seen this one before. I want a refund. Seen which one before? What did I miss? Oh, the pro tip. Yeah, oh shit, Teamstar's in Discord. I just noticed it on the overlay. Sorry, Teamstar. I meant to jump in there and wait for you, but I didn't. Hello. Sorry. I was a bit late joining the Discord. Um, yeah, our pro tips are a bit like we need to come up with.
Oh, I was confused because I just like opened the stream like in the browser.
Oh, you were hearing me on a delay. You were hearing me in the past. You were time traveling.
Yeah, kinda.
Yeah. I'm just checking to see if the exploit ran successfully because I think it did. But I always like to confirm. Yep. The exploit ran that time. We got code execution. Cool. So yeah, I don't know if you saw my tweet on Twitter, Teamstar, but I got code execution working.
I did.
Yeah, dude. Unfortunately, the crash log is really shitty and doesn't have like the really pretty text I put in the screenshot on Twitter. I don't know why it does this actually. I don't know if you do, but for some reason, when I get code hijack and like do that A instruction pointer hijack, um, in the kernel log, instead of doing its usual like stack trace and stuff, it just gives me this weird shit where it tells me what was called, but it's like missing a bunch of info. Like it doesn't have the pointers, like the virtual address or anything that was involved. I don't know why. It's really strange. But I can tell the exploit worked because in the crash log it has current ioctal and it traps and has the same panic. So yeah, cool. Although in a way we almost don't want the exploit to run first try when we're doing this because we want to test the retry. Oh, actually, in the trace it does show our pointer. It shows current ioctal and then it goes for 1 for 1 for 1 for 1 in question mark. So
yeah, so you get the log there.
Yeah.
Because afterwards it calls like trap handlers and shit like that.
Yeah, it tries to do the tries to handle the trap frame.
Did you fix the pointer endianness, or that's already a step further, right?
So bit of a fun fact. We didn't have to worry about endianness. That wasn't the problem. The problem was an off by 4. Basically, because like the data we're hitting, the file pointer stack, the pointers are all aligned to an 8-byte boundary, right? Yeah. But our data is getting sprayed. Like if you look at our M clusters, they always end in 4C. So because of that, we were 4 bytes off because we weren't aligned. So what I had to do was I had to make it so the pointers are offset by 4 in the packet that I spray. When I did that, it worked fine, and I was able to fake the file pointers properly.
Nice.
There were a few other like things I had to, like a few other steps I had to take before getting code execution. I kind of went through them at the beginning of the stream, so I won't go like as in depth on them. But I had to fake the reference count and the file type and flag fields because they were checked and they would like bail in the ioctal syscall if they weren't set to certain values. So I had to do a bit of messing around to get the fake just right. But after I got those fields set up, yep, we were able to do the ioctal function pointer hijack. So what I've been doing after I demonstrated how that worked and had the exploit ran on stream, I started implementing what we were talking about last night before we hopped off the stream, to try to rerun the exploit. So what I ended up doing was, first I increased the spray size, like we talked about. I made it hex 500. I also used those first 4 bytes of padding that I used to get the pointers aligned. I used that as the tag.
Oh, perfect.
Yeah.
Actually, they're just in each packet, right?
Yeah.
Okay, yeah, that works. Perfect.
So I have a tag set up to be sprayed, and then immediately after, I peek on all the mbuffs to try to find the second, like the next overlap, basically. And then I did what you were kind of joking about yesterday. I do a go-to, and I set this rerun variable. Oh, shit.
Yeah, that does not seem right.
I have a name collision between the label and the variable. Why didn't the compiler scream at me about that? It should have. Okay. Rerun thread 2. I can't believe the compiler let me get away with that, dude. That's probably why shit was blowing up. Okay. So yeah, I set this rerun variable, which then thread 1 will check for. Like, it'll wait until that's set to 1.
But you have still a collision with the label and the int on the second thread.
Oh, I just haven't updated this yet, sorry. I updated it in here.
Oh, I see.
Yeah. I'll copy that over, though, so it's not as confusing. Get rid of that. And yeah, so
I see.
there we go. Now it's there. Yeah, so basically thread 1 will run, and then it'll busy wait until rerun is set by this thread. When it gets set, it reruns and start thread kicks in again. The go-to just takes it back up to wait until thread 1 starts to race again. So yeah, I think this makes sense the way I have it set up. So we'll go ahead and test it. I was gonna test it on the last run, but it worked on the first try, so I wasn't able to test the rerun capability.
If your exploit is too reliable, so you can't test the rerun, you can like at the same time work on the cleanup.
Hey, I mean, that's a problem I'd be very happy to have. So, you know. So yeah. sh build. I do have the logging already going. Okay. Let's see if it works. Oh, it bailed out. Oh, because the overlap failed. Never mind. Different issue. Another one we might try to tackle, but I'm not worrying about right now. Okay, it is running the reclaim. It crashed. Okay, it crashed again. Why did it crash? Somebody says we might have forgot a rerun. We forgot to rename a rerun. I will check for that. I don't think we did, though. I think because the variable is still the same. I just renamed the label. So that should be good. The rerun variable, how it's used, should still be fine.
Okay, and any idea when it crashes?
So it reaches here on thread 2.
But wait, is it supposed to be inappropriate IOCTL?
Oh, that's fine. We get that on all the file descriptors that we don't corrupt because you can't issue ioctls on those file descriptors usually because the type isn't set up properly. But yeah, that was mostly there for debugging, to be honest. I can remove that actually to remove clogging the log.
Good morning, Chad.
Failed waiting for rerun. So yeah, this thread reaches this print, and the second thread reaches the reclaim finished print. So I would think if it's crashing it would have to be in this for loop.
Oh, dude, you should put like how's that shit called? A colon? No, not a colon, a comma in the printf. It's failed waiting for rerun, not failed waiting for rerun.
Get out of here.
I was a bit confused.
Does that make you happy?
Yeah, because grammar is the difference between knowing your shit and knowing your shit.
Okay, alright.
Anyways, back to topic. Fail. Okay, so is anything printed after the failed waiting for rerun? It's reclaim finished, right?
Wait a minute, I might be stupid. I think I might know what I might have done. I read out to the recipe packet, but I leave the pointer uninitialized.
Huh?
Just pretend that didn't happen. Just ignore that. Last 5 minutes didn't happen, dude. It's okay.
may need to resync the stream.
I told you like an hour ago. You just didn't care. Okay, sorry. I try to keep up with chat. It's sometimes messages just go to the void. You know. I must have just missed it. I'm sorry. I've had that happen before, where like chats point out little mistakes that I've made, but because like it gets buried. Because I have like a few monitors, but I have like the OBS on one, and I use the chat window in OBS, and it only shows the last 4 messages. So unless I go back and try to scroll through, it's easy for me to miss stuff. I gotta get another monitor. Like, I'd love to get a 4th monitor, specifically for stuff like that, for like putting chat and Discord and stuff on, but...
Dude, I have one single laptop and one single iPad, so that's...
I don't know how you deal with that shit. I don't know how you deal with that shit. OBS only showing 4 messages. It's because I only have a 21-inch monitor, and I have the activity feed underneath it, so it's like a split view. 917, you forgot to initialize rest feed packet. Ah, man. I'm sorry. Sorry for missing that. Yeah, it's not OBS's fault, Z. It's just because my monitor's like... I don't have a 57-foot monitor like you do, so... We can't have all the things displayed.
Do the overlap stability upgrade.
I wanted to tackle them individually instead of trying to do everything all at once.
Yeah, but why do them like backwards? Wouldn't it make much more sense to?
Because I don't really care if the overlap fails. That's recoverable. It's the second one that's not recoverable without a reboot. So that's why I'm putting the focus on the second one. It did fucking crash again though.
Why don't you run that in GDB?
I don't even know if I have GDB on the VM. I can see if I do.
Or LLDB or whatever.
If I don't have it, I can go into ports and see if I can build it, but I probably won't be able to. Or, I don't know, maybe I will. GDB might be one of the few things I could.
Yeah, I think that should be pretty standard. Either that or LLDB, I don't know if BSD is also into like the LLVM thing.
No. Especially FreeBSD 9? No, LLVM's a bit too recent for that. Let's see, GDB? Holy shit, we do have GDB. I don't even have to build it, dude. Wow. Okay. So, we'll do GCC, exploit this spec. Let's see, thread. GDB, spec.
You forgot the -G for symbols. Not that it matters.
Oh, okay. Oh shit, I don't have the kernel log running. I got it up just a bit late. We'll miss some messages, but that's okay. SigSegV segmentation fault. Corrupt file pointers. Okay, it is in the second thread that the crash happens.
Do you backtrace?
Nope, that's not what's there. Oh yeah, it was whoops there. I was looking at the wrong thing. Gas. Get out of here with gas. I know. You like gas, but I don't. Sorry.
What's gas?
GNU assembly syntax or whatever.
No, I like
AT&T
Intel.
syntax. Oh, you like Intel? Okay, for some reason I thought you liked this garbage here.
Hell no.
Yeah, this is the one true syntax. Let me get more instructions. It's hard to really tell what's going on.
I'm just saying, if you had recompiled with -G, you would have symbols.
I have symbols. See? I see, like...
But, like, actually source code line thingies. Yeah,
It'll
I
only
think
take
it
a
might
second
be
to reboot.
faster. Yeah, I think it might be faster too.
With Intel, I can now read it. Yeah. The only thing that sucks is, at least to my knowledge, with like the inline assembly, you're basically forced into using the garbage syntax. So that kind of sucks, but whatever. GNU inline assembly in itself is really shitty.
AT&T.
Gotta love AT&T, man.
Because you said GNU. It's getting late, right?
It is getting late. Yeah, it's 10 after 5 for me. I was thinking I might have been done by now, but we just keep rolling, man. Whatever, it is what it is. We'll keep going.
Yeah, man. Now recompile with a -G.
Yeah, do that. You can just use a .s file and link it with your C code. If you're just trying to run an assembly routine, you can do that. If you want to do something where you're like, you want to load a register using assembly, or you want to load a variable using assembly, then you have to use the inline assembler shit.
I'm pretty
really annoying.
sure you can also. There's ways around that. All right, see, there's the source code. recv packet tag is probably recv packet is probably 0.
Can I do?
Yeah, you can write p and then recv packet tag.
Wait, sorry, say that again.
Maybe without the $.
What? But I initialized it. What? Recipe packet. That's initialized, right? Does it get? Yeah, that should be fine. Maybe it got overwritten with an old file or something. Let me just try. Let me just see that. Maybe it did get overwritten with an old file, because that looks like the old bug that I thought we fixed. If you want to set a register, you can assign the register to a variable and set the variable. No ASM needed. It's like not as versatile though.
Yeah, you kind of always do that. Sometimes you need to have like fine-grained control. But
Yeah.
I think there are ways to get like Intel syntax and inline assembly. Pretty sure that's you can do that. It's just nobody knows how, because it's hella complicated syntax.
Well, the other problem is like inline assembly is not like it's not standardized at all. So like doing it in GCC is going to be different than LLVM, or yeah, like it's really silly. And then MSVC is even worse. MSVC is just the worst in everything. All my homies hate MSVC.
I don't understand anything, but it's really cool to see smart people do cool stuff.
I like that quote. It is fun to see, like I like looking at hardware stuff for the exact same reason. People who are doing like glitch attacks and stuff. Like I don't know how any of that shit works, but it's cool. Okay, let's just make sure, double sure that we're on the latest file, and then we'll run it again. Should be. Oh, let's get a fresh log here.
Wait, did you verify that the file is correct?
I can verify in here too, just to be doubly sure. Oh wait, that's thread 2. Here's main. Yep. Okay. Recipe packet gets malloc. See it here.
I can see it.
Watch your fans talk about PS Vita hacking. It covers glitching very, very well. I have seen it actually. I saw Davey and your fans talk. It's been a while since I've seen it, but oh shit, we gotta run it again. Yeah, that is a really cool talk, just in general, to be honest. Apparently, just the first line of the inline assembly should be Intel syntax. I know you can do that, but I think that might mess with the way that the way you set up the input registers, trash registers, and output registers or whatever.
No, I'm pretty sure you can. There's just definitely a way to do it.
Oh, okay. Oh, I think it is running multiple times now. Although it's kind of hit a roadblock and stopped, and
Yeah, it's kind of hanging.
I don't think no the operating system still works. Yeah, nothing showing in kernel log that shows that it would have blown up. Is that radiation coming from Teamstar's mic? I think they're saying your mic sounds like a Geiger counter or something with like.
Oh, I'm sorry. I'm eating like this. I don't even know what. Let me like look that up for you.
You don't know what you're eating.
That's some Russian candy stuff.
Okay. Damn, you're very trusting, huh? Eating something you don't know what it is.
No, I do know what it is. I don't know how to like call these. It's like called baranki. I sent
Oh,
a link
okay.
in chat.
Okay, I see.
So depending on how old these are like super hard. So for chewing that make like crunchy sounds.
Eating raw plutonium. Oh my god. How do you guys get so good at coding? What class did you take in university? Oh, yeah, I've never went to university, to be honest. Teamstar has. I just everything I know it's basically been self-taught.
Yeah, university usually doesn't teach you shit in terms of okay, that's probably not the way I want to say it. They do teach you stuff, but if you want to like be good at coding, you definitely need not to rely on what university teaches, but do it yourself. So I went to university and I took a bunch of classes there, but to get like into coding and hacking, you really need to do like self-learning. It's not like they like I don't know how to express that. Yeah, like put everything into your mouth, so you just need to chew, you know, you need to go out on your own and figure it out.
Oh shit, I see what I'm doing wrong. I'm reading in the
But
loop,
is it
but I didn't write the file descriptors back. So it's trying to read, but it's there's nothing there for it to read. So that's why it's fucked up. So we just got to move the for loop up, basically.
why is that an empty for loop? Why is it not a while loop?
Oh, that's just the way I like to do things.
Okay, fair enough.
It's just a personal
I would
preference.
still look at it in a very weird way, just so you know.
Okay. Yeah, forever is better than while. Yeah.
If it's free one, shouldn't it be free I or something?
Oh, this I just mean free one is in freeing overlap one.
Oh, I
The
see.
second thread frees overlap two.
Oh, why do you have in line 682 like I, not like the variable initialized there? Just gonna mock some of your code right now.
Oh, like why don't I have it like this?
Yeah.
Because I can't. I'm limited to
What do you,
C99 on FreeBSD's version of GCC. I don't have C11. So you
really?
can't do in loop declarations.
Huh. Okay.
I didn't know you spell ever as semicolon semicolon.
Huh.
I mean, hey, we all write in different ways, right?
True.
Yeah, I think this should be good. I think this should fix that problem. One. Yep, that's global. Yeah, this should be okay. All right, cool. Um, I DM'd Flo today, by the way, just to let him know, like, hey, I exploited your bug, but I used a different strategy and I got it to work.
What did he say?
I don't know yet. I don't even know if he's read it. I
Like,
close like some messaging apps while I stream just so that people don't accidentally, DM me something that shows up in a
oh,
notification.
yeah,
But
makes sense.
yeah, I'll check after the stream, see if he's received it, because I think he's in Switzerland, right? So it should be like middle of the day
Yeah,
for
I
him,
guess
right?
so.
Or afternoon or whatever. We're back. System's rebooted. Oh, Flats gave me a tip, by the way. I haven't looked into it yet. I'll look into it probably after the stream, but he said if you disable DNS, you can make FreeBSD boot like a lot faster or something. I was like, oh shit, never knew that. This Flats is like an endless like tip supply, man. He knows everything. I don't know how, but he does. I'm gonna keep running it through GDB just so I can get the information quickly if I need it. Now that I know that I actually have it. Ooh, thread 2 exiting. That shouldn't be happening. Thread 2 shouldn't be exiting.
It sounds like you do something right and something wrong.
Oh, you know why? It's because it failed to find the overlap again. And in this case, there really is nothing we can do. If we fail to find the overlap after, like to try to retry the race and we can't find it, then we are screwed. So, I mean, there's nothing we can really do there.
Can you rerun in this case? Like right now?
Maybe.
Because in that case, you would jump back to the outer loop where you retrigger the bug. Because on PS4, the alternative would be to reboot the system, which is actually super annoying. So if you can instead just retrigger right away, that would be better. Because
Yeah.
you don't have to close the process or WebKit in that case. You can just rerun it. You probably want to do like a proper cleanup then to find the lost packet, but I mean, can be doable.
Yep. I'm down to try that. I'm probably not going to do that on stream though, because we're already hitting like 5:30 my time. I don't want to go until like 6 again, so I'll probably jump off relatively soon here. I'm just going to give it another shot, see what happens. We can trigger it again, but I like the idea overall. I'm probably going to have to rebuild this because FreeBSD usually deletes the file that causes it to crash. Um, and we have to rerun our log script as well. Again, we failed to find the overlap. That's really, I thought we would be more successful in recovering the overlap, but I guess. Again, I think it's one of those things where there's so many different services running on FreeBSD where there's probably more interference than we'd like.
Sure, but there's probably still ways to bump up reliability. So let's see, what are you doing right now? Can you show the code?
Which thread do you want to? Well, we can look at both actually. I'm not sure if this is if the split view is up to date, so I'll update it myself just in case. Get rid of this. Let me just get rid of this shit in general because I don't use it anymore.
Okay, so the thread starts, it pops, and then you reclaim. You said you increased spray socket corrupt num to how much?
Hex 500 instead of hex
X
100.
500. Guess that should be good enough. Reclaim finished.
Maybe debugger slowing it down. That is actually a good point. GDB probably is
True.
slowing the shit out of the exploit.
What happens after the line reclaim finished on the second thread?
So you know how we increased the spray size of the push so that we would try to cache the free, like the free pointer that's left from the write or the read FD. Basically, this is just peeking all the mbuffs to see if we have another, if we manage to capture the overlap again.
Shouldn't you be synchronizing then? Because if you reach the printf reclaim finished, then you don't know yet whether you successfully like put the target thing in. Like maybe it worked at that point, so in that case you don't actually need to peek through the buffers yet. And also, yeah, you should probably synchronizing there. More variables, that will get messy.
Yeah, we'll clean it up eventually.
Sure.
Yeah. And other hilarious jokes we can tell ourselves.
Why don't you reuse the rerun whatever?
Whatever. So race window closed, and then we'll just while race window closed not equal 1.
You wanna on the first thread you wanna move that down though. You wanna move it right above the while rerun is not 1. Because you really only need to do the part if you know
right.
that it failed.
Yeah, you're right. Thank you.
And then after the rerun, you want to put race window closed back to 0. Or
yeah, that would be in the second thread. When we get
either way, you want to put it back to 0 somewhere.
Yeah. Put it here. All right. This time I think I will run it outside of GDB because that is a very fair point about it running slower. And with the race that we're dealing with, it's probably significant. So we'll just run the normal one that I have after I upload the new file.
Hello, how are you? How are they?
I think everyone's doing good. Overlap failed. That's fine.
They are great.
Yeah, I think we're all doing good here. It's been a fun day, man. It's always nice when you like take an exploit to code execution. It's like a sigh of relief, I guess, after dealing with as much bullshit as we have.
Overlap failed. Next stream we will tackle the rerun thing. Or do you want to go straight to WebKit?
Might go straight to WebKit. Oh. Why is thread 2 exiting?
I mean,
because it failed to find the overlap again. Fuck, man.
Yeah, the change we added doesn't really solve the issue. It was just like another thing.
It was just a fallback. The fallback, unfortunately, is like I thought it would work more than it is, to be honest. But oh well. I'll give it maybe one more run and then we'll probably cap off this stream. Yeah, just see what happens with another run. So, since I've gotten code execution, I have started up a little bit on my write-up. I have a lot of fun doing the PS4, well, just write-ups in general. I love doing write-ups, so I've gotten started on that, man. We've gotten a bit of the background
Nice.
information written, and yeah. Add a go-to the beginning on thread 2 exit. That won't really help though, Belika, because at that point we've lost our overlap. We have to trigger the double free again in order to do anything. So whether or not we bail out isn't really relevant. We would have to add code to make it rerun the double free again, basically, which will take some reworking to make it work properly. Spectre resists the exploit will be more stable than Slayer Scovies. I can't really answer these questions. It's
hard to tell.
Yeah.
You
I
can't
mean,
know
I can
that
theorize in my head, but I can't factor. I'm not a supercomputer. I can't simulate all the factors in my head for stability. Yeah, it seems like it's really hard to recapture the overlap. It seems likely that we lose it if we thing. So
Yeah, so it probably needs more looking into that. I guess we may want to like from now on move to the PS4 and then
I'm
back to
thinking that
Visual.
too. I think we might want to move
Yeah.
to the PS4. Because some of these like scenarios that we're testing out are getting pretty specific to the circumstances on the BSD VM. So yeah. Overall, like today's a big win though, getting the code execution. So do try to keep chat English, guys. I will delete non-English messages. Usually Z does that for me, but he had to go to bed. So yeah, just try to keep chat English because we're an English stream. Yeah, I'll give it one more attempt here. We'll give it 3 times the charm. But yeah, at this point, it's mainly just increasing stability and then doing the port to PS4. So, and then we might do that all in the same. We might port it to PS4 and then work on stability then. That way, we can target the circumstances better. This is interesting. I think it hung or something. What is going on here? Oh, the overlap failed. Okay. I've seen a lot of people on Twitter saying like my strategy is automatically going to be like the best and most stable because 5.05 was so stable. I think a lot of people fail to understand the reason 5.05 was so stable is because QWERTY's bug was just amazing. Your stability is going to be tied to your bug pretty heavily. You can try to influence it, but you're like, if you have a really good bug, you don't even need to mess with stability, dude, because it's already built in. You already get it, and that was kind of the case with the BPF bugs. They were really solid.
Did you get
bugs.
just 2 runs?
Did I? I wasn't paying close enough attention.
I think you have.
Yeah, I think I did. Although neither of them worked. So it's cool that we got 2 runs, but yeah, I don't know.
Yeah. So we just need like more stability upgrades and then we're good. Just add like a reliability.
I wish this were like a mobile game. You know, we could just buy some stability crystals
Some
for like
perks.
$5.99.
Yeah, I was literally thinking that.
Instead of having to do all this like research and manual work, we just do some microtransactions and take it all the way. Yeah, I think we're gonna cap it off here though. Thank you to everyone who tuned in. Any last minute thoughts in chat? Feel free to leave in there. I'll try to address them. Spectre, you were the king of PS4 jailbreaks, and Team Story, you're the king of iOS jailbreaks. Yeah, I mean these streams have been fun to do like together and combining the experiences. I don't know if I'd say I'm the king of PS4 jailbreaks though. Like I've been involved in a few. I definitely don't want to say like I did it all alone or something though. Like you know, 4.55 and 5.05, a lot of that was QWERTY. It was his vulnerabilities, right? So, yeah. I've had a lot of help in like the PS4 scene, so I definitely don't want to, you know, pretend like those people aren't there. I've had a lot of help along the way from people like Flats and QWERTY and some other people out there. So, but yeah, we got code execution. Next work will be on porting. I don't know exactly when the next stream will be. We'll have to see. I don't think I'll be doing one on the weekend, but that could change. I kind of just see what's going on that day, and if I can fit a stream in, then I'll do one. In regards to a scenario where a jailbroken console can go online, that's never going to happen, or it's probably not going to happen, because the way Sony designed the console is smart. Even if you have a 0-day, if it gets out there and you can go online with it, you're not going to be able to go online with it for very long, because there'll be a firmware update out pretty quickly. So, yeah, other than that, though, thanks for everyone who tuned in. Thanks also to some of the people who helped out, you know, like Little Alo coming in. We had It's CN as well. And obviously you, Team Star, for coming in. But yeah, other than that, we'll do another stream. Follow us on Twitter and in our Discord to see when that is. I always put the notifications there when I'm going live. And if you're in a Discord with me, you can see on my name if you're in a server with me on like Open Orbis or something. But yeah, other than that, I'm going to go ahead and jump out. Thanks to everyone who tuned in, and I'll see you on the next one.